All right, hello and welcome to the September 2021 event for the Atlanta Kubernetes Meetup. We're a few weeks out from KubeCon right now, but we've got some exciting content before all of that tonight with Michael Solberg from Red Hat speaking. As always, we like to open up with a call for hiring in the community. If you, or your company you're affiliated with are hiring anybody in the Kubernetes or cloud native space, go ahead and post information about that in the chat, including contact information if you have it, and links to the job where they can apply, things like that. And I will read those out after the news, and we'll also post those in the show notes. And to go ahead and give you time to do that, I'll go ahead and hand over to my friend Joe to kick off with the news.
All right. Let me jump over to our notes here. So we're going to cover our normal batch of news, starting with the Kubernetes release cycle. We are in the version 1.23 release cycle. Recently, the 1.23.0 Alpha 3 release was dropped. Upcoming deadlines here, cherry picks are due on October 15th, and the last call for exceptions going into the 1.23 release freeze is November 1st. So if you've got any changes going in upstream for this release, make sure you mine in your P's and Q's as far as all that goes. We did have some fixed releases that went back to 1.19. So 122.2, 121.5, 120.11, and 119.15. There were a few fixes, and then these were also sort of prompted by a couple new CVEs that we'll talk about in just a second. Feature promotions of note to call out is the IPv6 dual stack enhancement was graduated or is graduating to generally available in Kubernetes 1.23 release. So that's really cool to see. I know the kind of mixed bag of who's using IPv6 out there and not, but really nice to see that these can coexist together. So CVEs, there's two. And I don't want to go into a whole lot of detail here, but we do have links to some GitHub issues that go into more detail. But essentially, one is related to a vulnerability with Kubernetes webhooks when you have the -- profiling Kubernetes API server flag, or you have the verbosity set to 10 or higher. You are vulnerable to that. And I don't think there is a specific fix that has been released for this yet. So if you are using the profiling, or you do have your API server logs of verbosity 10 or higher, check that out and look at some of the things that you can potentially do to mitigate around that. The other CVE, which I believe was patched in the latest fix releases mentioned earlier, is around the use of the host path and the volume subpath mounts. We've seen a lot of vulnerabilities around this. This stuff is hard when you have a lot of things all running on like kind of a single underlying worker node file system, and making sure escaping outside of the bounds of some of the runtime components and things of that nature aren't there. So not super surprised to see another vulnerability in this space pop up, but it is important all the same. So this lists out the affected versions. And as I mentioned, those new fix releases that were dropped do include a fix for this in there. PRs of note. So this was an interesting one. Adding UID impersonation to client Go. So there's a couple different, there's an impersonation library inside of client Go that allows for things like testing different commands that might be run as a particular user or a group or things of that nature. And this new feature is kind of the second part of some ongoing work. The first part was to add the UID impersonation headers to the requests, client Go requests, and then this part kind of consumes that information on the server side to allow for UID specific impersonation. So pretty interesting stuff there. And then we'll jump into community news, and there was quite a bit. So first, there will be no formally organized contributor summit at KubeCon North America 2021 this year. And we still have a social event on the Monday, the week of KubeCon, and all of the online contributor celebration that was scheduled for December will still take place, but none of the normal workshops and things of that nature for Contributor Summit this year due to kind of low registration. Did have a KEP here on CRD validation expression language. So this was really cool. This kind of overlaps with some work that I've been in and around lately, where there's a fairly limited set of validation controls you can put when you're building out Kubernetes CRDs. And that those are based around the OpenAPI v3 schema validation. This enhancement is sort of set to add a more expressive language for those CRD validations. This common expression language, CEL, is the target of that would allow for kind of much more advanced and complex validations within the CRD itself, versus having to build out like a separate validating webhook to implement some of the higher order logic there. So really cool to see the enhancement come in for that. Kubernetes API server tracing. So this was an article, yeah, on the Kubernetes blog that I thought was pretty cool. We've done a couple talks this year into distributed tracing and open telemetry, but in Kubernetes 1.22, the Kubernetes API server tracing is in alpha, I believe. And this is some really cool stuff. Won't go into a whole lot of details, but it does sort of enable you to start and trace Kubernetes API server calls. So that means going through and, like, if you have a large number of validating or mutating webhooks and you start to see some slowness in your overall API calls, like, you can trace that down and kind of see where the slowness might be. So always good to have additional observability into things like that. Cluster API provider nested. So there's been a lot of stuff out there, tools to enable you to create Kubernetes clusters in lots of different ways for quite a while now. And it's always awesome to see even more ways pop up, especially when they are sort of like the inception type models of like running Kubernetes clusters inside of Kubernetes clusters inside of Kubernetes clusters type thing. So, but we've talked about cluster API in the past, where it has this provider model for the different component, like high level components that are required for a Kubernetes cluster, like the infrastructure component, the bootstrap component, things of that nature. And this allows for a slightly different model, to where rather than talking to an infrastructure provider to provision virtual machines and things of that nature, this can talk to an existing Kubernetes cluster and provision a nested Kubernetes cluster, which has all sorts of interesting use cases and whatnot that I won't go into. But if you're looking at kind of further levels of multi-tenancy or enabling power users while still maintaining a lockdown of like cluster scope things, this is a pretty interesting model that might be able to help with that. Really cool to see all the work that the cluster API community has been doing. Kubescape, you know, security, it's a big thing in Kubernetes these days, and always a threat out there. There's lots of really awesome security tools. This was an interesting tool because it sort of, it can, you know, work in CI and also work in the runtime, you know, kind of area. But it brings in the Kubernetes hardening guidance from the NSA and the CISA to be able to essentially kind of ad hoc report on a running Kubernetes cluster or manifest for a Kubernetes cluster against known baselines, and kind of give you a pass fail, as well as additional information about what particular controls that you've passed or failed. So pretty interesting thing there. Really cool to check out if you're into the security stuff. super edge. So lots of buzz around all things with edge computing and whatnot. And this is a pretty interesting spin on how to manage some of the resources at the edge where you might not have access to the same full infrastructure stack that you do in like your public cloud providers or in your own data centers. So you want to run things a little bit leaner. This provides a way to sort of manage those resources and your applications deployed across like multi-region edge topologies. So really cool thing here. There's a lot of moving parts into how this works, but it essentially has some like VPN type connections back to control planes. So this can be distributed out across non-contiguous like network topologies and things like that, which is pretty interesting. And one of the models that they use that I thought was really interesting is they have sort of a two-stage API server where the full API Kubernetes API server is back in a centralized place, and there's a sort of light version of the API server that's deployed at the edge. So it mitigates some of the normal problems you might have with like latency concerns and things like that. So pretty interesting, lots of flexibility in the model. Karmada. So this is another interesting project that seems very similar to the one of the presentations that we had recently around sort of a federated Kubernetes experience of deploying and managing workloads to a single API endpoint that then gets scheduled and actually deployed to run across multiple Kubernetes clusters on the back end. This one has some slight differences between some of the stuff we've seen in the past. And this like K's native API compatibility, like zero changes in what your workloads look like. It handles the distribution for you is really cool. This is no like vendor specific lock-in or anything like that. But there's also some cool stuff where they allow for like cluster affinity, multi-cluster splitting and rebalancing, and in multiple dimensions there for the high availability across regions, availability zones, clusters, or providers. So really interesting model here. And there's a lot of other models to where you can have like sort of active passive or rebalance replicas across multiple clusters. Lots of really cool stuff there. Some more Kubernetes edge stuff here. It's probably butcher some of these names, but ACRI, Kubernetes resource interface for the edge. So this was interesting in that you have a lot of sort of different types of microcontroller devices at the edge that could be sensors or cameras or this, that, or the other. And this project sort of builds on top of the Kubernetes device plugin framework to allow the discoverability of those types of devices and then sort of share them out through a common broker interface to where other workloads inside of the Kubernetes clusters can interact with these type of devices in a sort of shared capacity. So really, really interesting stuff here. They have a lot of different use cases sort of documented, the architecture. And then they also have some cool like end-to-end demo stuff within like a Raspberry Pi environment. So really cool if you're into that sort of like microcontroller edge compute stuff. And then Enclavare, and I'm probably, again, butchering the name there, so apologize in advance, but confidential container runtime tooling. This is a lot to unpack. This project's extremely complex, but we had a question from one of our normal, our regular Meetup members around like, is anybody doing anything with trusted compute platforms and Kubernetes? And so this is sort of getting into that wheelhouse where it does a sort of spin on the normal like run C type environment and has a shim layer that it injects in there. But essentially what this does when it talks about confidential computing is when you deploy workloads to a like public cloud provider, that's infrastructure that you don't have access access to. You trust that the provider is doing what they should be doing underneath the covers and things of that nature. Well, over the years, different vendors like, say, Intel, for instance, they have a lot of trusted compute platform functionality exposed through the processor interface that can be bubbled up into something like a container runtime environment. But this project has a lot of moving pieces that essentially, whether you're deploying into your own data center, you're deploying into a managed Kubernetes cluster in a cloud provider, you're deploying on VMs, Kubernetes on top of VMs and a public cloud provider. It essentially allows for a secure enclave to run inside whatever compute unit gets scheduled, and has a topology of attestation set up that you control. So even if you don't own the infrastructure stack, you can still have a kind of sort of like trusted runtime or trusted compute platform here. And even to the point of exposing some of those hardware components to ensure that in some ways. So not going to try to talk about it any more than that. So Eldon, I'm going to tag you, take this and look into it. But there's a lot of stuff here to where there's a couple different runtimes that this supports, where there's a specific, this Occlum sort of operating system environment, but they also have a WebAssembly micro runtime that still has all the attestation pieces built in. So very, very cool stuff going on here. If security is like of utmost importance to you and you're into the trusted computing stuff, definitely suggest checking this out. This was done primarily by Alibaba and a couple other folks, and in some cooperation from Intel as well.
Super cool. Yeah, I'll roll it out there.
Nice enhancements to cluster API here as well. So this is around what's called cluster API, cluster classes, and managed topologies. And essentially what it is with cluster API is it allows you to define, like, for clusters that share a lot of configuration pieces, if they're using the same infrastructure provider, they're using a lot of the same sort of like templates, if you will, for what your worker nodes look like or what your control plane nodes look like. These new enhancements basically provide those templates to where you can define it once and then reference those templates in your cluster definitions. So you're reusing config versus having a lot of, copy paste duplication there. But we've seen this happen with a lot of the Kubernetes APIs where we get a reference to a class like storage classes and ingress classes and things of that nature. Really cool to see this come into cluster API. And then Kink, again, with sort of the nested Kubernetes model here, but hopefully most of us are familiar with Kind, the project that runs Kubernetes inside Docker containers. This project builds on top of that. And it sort of allows you to deploy Kind clusters inside of Kubernetes itself. So if you already have a Kubernetes environment running, you can deploy a Kind cluster there versus deploying one locally on your laptop. Further enhances out like all kinds of granular things with CI. There's a lot of potential to where, like, not every developer or software engineer has a laptop where they can run a Docker desktop type component on there, or maybe not have enough resources to run multiple Kind clusters. So this solves around some of those things. And again, just really, really cool to see the different ways the community comes up with to build Kubernetes clusters in different ways. And that wraps us up for this month in Kubernetes. So I'll turn it back over to you, Alex.
Awesome. Lots of cool stuff happening this month. I'm sure we'll see even more interesting stuff coming in next month with announcements around KubeCon. We have a couple of quick job announcements. So our speaker today from Red Hat has shared a couple. They are hiring a cloud specialist solution architect, as well as a senior cloud specialist solution architect. And I'll post those links in the chat in just a minute. And then our sponsor, SalesLoft, is also hiring for a role. So I'm going to hand the mic over to my good friend, Brian Smith, here to tell us a little bit about that real quick.
Hello. Thank you. Yes, SalesLoft is hiring for the site reliability engineering role. If If system design, Kubernetes, and scaling multi-cloud infra is your thing, hit me up. My email's in my Zoom profile, and I'll post a link to the description, to the job description.
Awesome. I can personally vouch for that one. That's a great role for anybody looking to do a lot of Kubernetes work and a really great team, great culture. Awesome. So on that same note, I always want to say thank you to our sponsor, SalesLoft. They provide us with the Zoom license that lets us run this as a webinar and all that fun stuff. And in better times, provide us with space and AV and beer and pizza and all that other wonderful stuff. So thank you to SalesLoft as always. So during the presentation, you can ask questions using Zoom's Q&A feature. You should see at the bottom of your bar there a little square for questions and answers, Q&A. Click that, type in your question, and Michael will answer your question when he sees it, or Joe and I will grab him and call it out. He told me earlier he wants to make sure this is kind of conversational, so don't be shy. Make sure to throw your questions out there as they come up. And then make sure to stick around after the presentation. We'll have our open social time as we always do, where we'll let everybody be able to get on video and chat and spend some social time together. And with that, I will go ahead and hand over to Michael Solberg. He is an architect at Red Hat, and he's going to be talking to us today about data science workflows on Kubernetes.
Hey, thanks. I am coming to you live from a basement here in Grant Park, and it looks like it just got really dark in here. So I don't know. I hope it's fine. Let me share my screen here. Cool. And I just saw that we have a chat as well. Great. So today we're going to talk about data science and Kubernetes. Let's see, I'll just go ahead and lead into here. So what I want to do today is I want to talk about data science 101. So if you're not familiar with data science, walk you through kind of what is data science, how does it work, and what are the kind of problems that people are having when they're trying to get started doing data science. We're going to identify two problem areas in the traditional data science workflow, and we're going to talk about how Kubernetes in particular can solve those problems, and the kind of two things, kind of solutions to the problems. First off, we're going to talk about the Kubeflow project and the corresponding OpenDataHub project, which kind of solve the first of the two big problems in data science. And then we'll talk secondly about applying microservices and event-driven architecture to data science model deployment as a way to kind of solve the second kind of quandary or problem, I guess I would say, that we typically see when organizations are approaching data science. So enough about Kubernetes, let's talk about me. So I'm Michael. I've been at Red Hat for a while. I'm coming up on, I don't know, is it 13 years or something? I kind of have done three things at Red Hat. So when I first started, spent a lot of time taking people from traditional Unix to Linux. And then I spent some, I guess they were really long days, but short years working on OpenStack. I still work a lot on OpenStack. Did that a bunch, particularly in Wall Street, big banks area. And then the last 5 years, I've been working a lot on Kubernetes. So obviously OpenShift, our platform, runs on Kubernetes, and we've been doing Kubernetes since before Kubernetes was cool, I guess. I love my job. I've had a lot of fun working at Red Hat. We've done a lot of really cool projects. Some of our public accounts that we can talk about, places like UPS and Delta here in Atlanta, and we help them with their web properties and also a lot of the really cool technology that those companies are doing that I get to use every day when I get my package notifications or change my seats or things like that. So it's been really cool having that experience. And then the most important thing that you should know about me for tonight is that everything I know about data science, I learned from a very short course on Coursera. So it's like the kind of modern equivalent of a correspondence course. And I learned a few things on Kaggle as well. I did not get all the way through the IBM data science certification journey. I got to the Python chapter and was so bored that I couldn't finish. So anyway, I don't know much about data science, but I do know some data scientists. And anyway, that's that. So 101. So I'll give you the 101 that I learned in my correspondence course on data science and just talk about what it is. If you think about when I was in college, like 20 years ago, whatever, we called this thing artificial intelligence. And artificial intelligence kind of turned into machine learning. And then maybe 3 or 4 years ago, someone was like, hey, no, this is not cool because they're not scientists. So they came up with the term data science, and then kind of I'd say like a methodology of data science has evolved that really is a discipline at this point. So it is a well-defined discipline and methodology. And if you go out and hire a data scientist to come work for your team, they will work in this, workflow. So what do they do? So let me kind of describe it to you. And I have a couple of different projects that I can kind of put some details to, some real world details to how this works. So the very first thing that a data scientist does when they get started is they try and identify a problem that they want to solve, and then they're going to identify, what would the metrics be. So a great use case that we got to work on with HCA. So HCA is a hospital, I guess they're like a hospital owner operator in Nashville. They have a bunch of hospitals in North America, and they brought in a guy who's actually a Wall Street quant. So he was, a guy on Wall Street. He was doing stock trading and micro, trades and stuff like that. And he was like, I think I'm going to go help some people. So he went to go work for HCA, and he brought the same skill set, right? And so they said, hey, what's the first thing that you want to work on? And they were looking in the hospitals, and they found that there's a problem that they thought they could probably solve around a disease called sepsis. And I know, like, Alex, you were, well, anyway, so the sepsis, like, as you're in the hospital and you get a really bad infection, and then the infection, your immune system tries to beat the infection and ends up killing your own body. So a terrible, awful thing, right? But they knew that early detection of sepsis in patients would lead to much better outcomes, right? So if you find that this person's going into septic shock early enough, you can pump them full of some kind of antibiotics or something and save their lives. And so anyway, he set out to look at sepsis. And what they found, first of all, was, they said, here's the problem, is we want to, we got the sepsis problem. And then their metric was they want to improve patient outcomes, by a certain percentage, right? So they got the problem and they got the metrics. And that's step one, right? And so then step two is well, what data do we have that we can use to kind of solve this problem? And what they found in the hospital was, they have all this telemetry on their patients. So they know their temperature, they know blood pressure, they know, whatever blood work has been coming in. They've got a past history for the patient. So they kind of start sifting through all that data and looking at it and figuring out, how can I measure this data? What format do I need to get it in? What's relevant, so on and so forth. And so that's kind of step two. Now, the first of these two stages, and particularly the very first stage, like, there is not a computer problem yet, right? So that's very much like, an organizational thing, or it's a personal thing, but there's no like real computer problem until you get into data cleaning. And now the cleaning of data can be, it's a whole process, and we'll take a look at it real quick. There are products that you can use to build data cleansing pipelines, things like that. But this is kind of where you start to get into, the need for computers. And then, kind of the next step, once you have the data and it's clean, you got the problem, you got the metrics, is that you need to do what's called feature engineering. So what feature engineering is you're going to take a look at the data that you have, and you will take a look at, what you think a model might be that would help you do some prediction on it. And then you start to look for what they call features in the data that will help you predict the outcome, right? So if I'm thinking about sepsis, I'm trying to predict that a person will have sepsis or will not have sepsis in a certain amount of time. I have all this telemetry on all my patients. Well, what are the things that actually are good predictors? Is temperature a good predictor? Is a combination of temperature and blood pressure a good predictor? Is something in the blood, so anyway, that thing is called feature engineering. And that's the thing that you cannot learn how to do in a correspondence course. You have to go to school for that thing, right? But it does require a computer. So we're in the world of needing computers because a lot of the ways that you do feature engineering is that you shake models, you apply them, you see what happens, and then it kind of helps you figure out what the features are. So once you got the problem, then you got the data is in good shape, then you've figured out kind of what your approach is going to be and what the features are that are important. That's when you start building the model and training it. And we'll take a look we'll do some model training this evening. I don't have any GPUs, so it takes a long time, but it'll be fun to watch. And you start building, kind of training this model, and you tune it to get to the point where you start to get really good outcomes, where you get strong predictions that you can then validate and turn out to be good. And that leads you to kind of the next stage in the model process, which is validation, right? So I take all my training data, I train the thing, then I take some real world data and I start feeding it into the model, and I see how well the model performs. And I can walk you through that as well. And then you have a model, right? So you have a model, you feel pretty confident it can predict. Then you go into the deployment mode. And this is where your skill set as a data scientist maybe is not going to get you where you need to be. And a lot of times when you're deploying a model, and we'll look at this, it's really 5 lines of Python code to actually run the model on something, right? So you don't need to be, an application developer necessarily, but you might not know the best way to architect the deployment once you get it out there. And so that's kind of we'll spend the back half of the talk today talking about deployment and different ways to do deployments and why that's important. But that's really much more of an application architect skill set than a data science skill set. And then the last piece, once you get the model out there, is you need to validate that the model is performing like you want. And you do that through monitoring. There's a lot. So like I said, data science 101, right? The important thing about this that you have to remember is that you never start with a problem and get to a solution and then spike the football and walk away. Like the whole time that you're out here deploying this thing, you're going to be constantly validating, is the model working? Because the model can drift. The data coming in to the model can be different over time, and that can lead to model performance issues. And so you got to keep monitoring that model, and you got to keep making sure that it's performing, as well as you want it to. And then very important, are you actually improving the problem, right? So if you think about the sepsis story at the very beginning, are we improving patient outcomes? That's the metric. Well, if we find out that we are not actually improving patient outcomes, then we did a whole bunch of work. And, we didn't do it right? Because we didn't get out, get the outcome we were looking for. So then we start kind of back over into feature engineering, model training, model validation. The good news on the sepsis story is HCA did have a really positive outcome when they started deploying this out to the hospitals. And it was able to save an awful lot of lives, that's amazing that, you kind of think about your technology having that kind of a positive impact. So very cool. So that's the other thing I want to point out here too, since the process is iterative, it should remind you of another process that's iterative that looks a lot like this, which is software development, right? I'm kind of got new features, I'm putting them in here, I'm deploying it. Now I'm monitoring it. Now I'm finding performance problems or I'm finding bugs. I need to go back to the beginning and kind of start this iterative cycle. And so the data science workflow, it very much resembles and should resemble an application development lifecycle work stream. All right, I'm gonna stop here and see if anybody's got any questions.
Doesn't look like there are any in queue right now.
All right. Perfect. So what are the problems we're trying to solve? Well, first off, so how do I do the part in the middle? Remember I said in the part in the middle is where you need a computer. The tool that everyone seems to be using these days is a tool called Jupyter. For a long time in data science, the R programming language was really in vogue. If you go back before we called it data science, people were using things like SAS. People still use SAS, obviously, but not as much as they used to, or SPSS. And if you go back even further, at some point I remember we rolled out Beowulf clusters that did something. I don't know what in the world they were doing, but Jupyter is kind of the thing today. Like everything is basically written in Python. All the tools that you need to do feature engineering, model training, and validation are all available in Python. And the way that data scientists like to run Python is in Jupyter. We'll take a look at some notebooks here in a minute, show you how that looks. The quandary, kind of the first problem that you run into in this whole thing is like everybody knows they want to use Jupyter, but how do they get started, right? So most data scientists are not computer scientists. And I remember I was working with a guy who's a Linux guy, and he said, my company just hired these 6 data scientists, and they all came from different universities, and every single one of them needs a different version of Python, a different version of Jupyter, a different version of scikit-learn. He's like, I don't know what any of this stuff is. It's driving me crazy, right? And what you'll find is, even if they have enough of a computer science background to get this stuff installed on their laptop, they're probably using a different version of Jupyter or Python or whatever on their laptop than you're going to use in a Kubernetes cluster, right? Or that you're going to use if there's still a Beowulf cluster, whatever that is, right? So this is kind of classic works for me problem that you see in software development, same thing in data science, right? So that's a real, it's a real issue that people run into. And I remember when I was talking to that guy, he was like, we just kind of pointed him to some links on Anaconda distributions and things like that. And we worked through a couple ideas with Ansible and stuff. And he said, gosh, I really think I could solve this problem with Kubernetes. And at the time that he told me that, I was like, well, that sounds like a terrible idea. Because in my mind, data science was like thousands of nodes and giant Hadoop things and Spark clusters. And I could not even imagine in my mind that any of this stuff could fit in a container. But he was absolutely right. And, a few months later, talking to him again, he's like, oh, yeah, we're doing this thing in OpenShift. It's amazing. It solved all my problems. And I was like, oh, wow, I should really learn how to do this stuff. So that's kind of what got me started on my journey doing this stuff as well. So problem number 1 is how do I get started, right? So once I have the data, once I've collected it, once I've cleaned it, how do I get into Jupyter? And how do I do that consistently, right? Problem number 2 in the data science workflow is, like I said earlier, I'm a data scientist. I got 5 lines of Python I need to run. How do I do it, right? How do I do it? How do I scale it? How do I put it in the cloud? The actual thing that's being predicted, or the data that's being used to create the prediction, how do I get that data to the model, right? If I'm talking about data in a hospital, maybe all this stuff is being collected in a thing like Epic. Well, can I pull from Epic and can I run that? I've kind of got an integration problem there, right? We're working on a project right now, which is actually identifying liquor bottles. So it turns out that liquor bottles are like inherently, for whatever reason, inconsistent, and the barcode is never there. And so we're working with a liquor distributor, and they were like, hey, look, we have this huge problem, which is that we can't deal with broken bottles or unboxed bottles of liquor or whatever, because we can't ever figure out what it is. And so one of the guys on my team has actually been working on a model that identifies different types of liquor bottles, right? Well, that's going to be a very different project, right? So that project, you're taking pictures of liquor bottles, maybe on your cell phone, and then you got to somehow get them into the pipeline, and then the model's got to look at the picture and then predict, and then you got to get some kind of notification back. So anyway, these are all software development problems, right? And that is not in the realm of data science. It's not a thing you learn in data science. And so that one is a really difficult one to solve too. So it's really these 2 pieces that kind of the magic of Kubernetes and modern application architectures makes really simple, believe it or not, kind of problems that seem really difficult actually become very simple once we just treat the data science workflow like any other application development workflow. So I'm going to pause there and ask anybody's got any questions?
Don't see any in the queue. Again, people, remember, throw your questions into the Q&A feature if they come up. And if you can't figure that out, feel free to throw them in chat as well, and we'll translate them for you.
Yeah, I don't think I've said anything outrageous yet. So, all right, let's talk about the first problem. So how do I get started, and how do we solve it inside of Kubernetes? So the first thing, and this has been around for a while now, is a project called Kubeflow. And the idea here behind Kubeflow is we know basically what the tool set is. And in particular, I think when Google started Kubeflow, it was very much a, how do I get TensorFlow in front of people to basically to consume more Google Compute in GKE, right? And you never just use TensorFlow by itself, right? You use TensorFlow inside of a Jupyter notebook, or you use TensorFlow with all of these other pieces. And so, you know, Kubeflow kind of became this like opinionated distribution of all the data science stuff and the machine learning stuff in one place. So I can say, hey, I'm going to go install Kubeflow and I'll get everything that I would need to get started. What are kind of the components in Kubeflow? You have at the high level, the very specific ML tools, things like Jupyter, a bunch of Python libraries, things like scikit, scipy, numpy, pandas, things like that. TensorFlow is a very important thing. We'll be using some TensorFlow later on in here. And then a couple other ones that I don't even know how they are or what they work, right? And then you kind of have a middle area here. It's a bunch of operators that make it easy to install these things and manage them. You have kind of the Jupyterhub notebook stuff. And then a couple other things that are going to be familiar, things like Istio, Argo, Prometheus, Knative to some extent, and KF serving, pieces like this. And we'll kind of look at a lot of these different pieces together, but just kind of stuff that you use kind of as infrastructure to support the AI and ML tools at the top. And then at the bottom, you know, obviously it runs on Kubernetes. What is Kubeflow? What does it actually look like when you kind of want to take a look at it? I'll bring it up over here. Yep.
Really quickly, Michael, we had a couple questions come in. One of them just a very specific. Do you use Databricks in your tooling stack?
I don't. Yeah.
And then the other one is a user saying they're new to Kubernetes, and maybe if you could give a brief overview of what part of this Kubernetes solves. But I imagine we'll probably get into that as we talk about this.
Yeah, absolutely. You know, Kubernetes, the kind of magic of it, from my perspective, is it's very good at, first of all, taking, you know, software that, how would I say this? Like kind of software that's written and packaged in a whole bunch of different ways, and kind of running it based in containers, right? So kind of the first layer of Kubernetes is the container layer. So everything's a container, so it's easy to deploy. And then the next layer of Kubernetes is scheduling and gluing things together and networking and pieces like that. So kind of taking all these disparate pieces of software and making them all deployable in exactly the same way is kind of the magic of Kubernetes from my perspective. So if you look at Kubeflow, you know, in here you can see if you've used Kustomize in the past, it's a set of customized manifests, and you can absolutely use it with Kustomize. But if you look kind of at the apps here, you have things like TensorBoard, you have things like Jupyter, KF serving. These are all different tools that are all deployed or kind of written and packaged in different ways. Some of them are just available as source code. Some of them are Python projects, you know, pieces like this. But each one of these things, when containerized, all deploys exactly the same way. And kind of with the magic of Kustomize and all the different Kubernetes objects, they can all be easily deployed, configured, and managed you know, fully declaratively. So to me, that's kind of, you know, the high level value of Kubernetes for AI and for ML workflows. So like I mentioned, Kubeflow is a set of manifests, and you can kind of see it in here. Kubeflow manifest. I should be dropping these links maybe in the chat. Let me do that. And if you only want to use certain pieces of Kubeflow, like I said, you can absolutely just use it like you would use any other customized project. But there's also a concept of distributions. And let me kind of come back to here and show you what this looks like. So, and I have a note here, you know, if you're going to start from Kubeflow from the very beginning, the place to start is you go to kubeflow.org. It is confusing for me. I've been using Kubernetes for like 5 years, and when I tried to do Kubeflow the first time, I could not figure out how to actually get started. There's a very nice video that Google put together with like a very energetic person talking about the magic of Kubeflow. But then once I tried to get past the like overview video, I really got confused pretty quick. And let me explain why. So if you've done customize and you have a Kubernetes cluster and you know how to do it, then just jump to step number 2, right? But if you haven't done customize, and I'm not a big user of customize myself, there are what they call distributions, and the community, you know, I would say, you know, is kind of strongly, you know, would recommend that you do a distribution. The reason for that is that, you know, whereas you might be able to run customize and get all the software kind of thrown out on a Kubernetes cluster, you might not know how to size the Kubernetes cluster, and you might not know, you know, what kind of, I guess what I'd say, you know, like what kind of capabilities a cluster has to have, what kind of sizing it has to have, you know, any kind of admin setup, things like that. So that's why they kind of would recommend that you start with what they're calling a distribution. They're in the process of revamping this particular documentation. So when you first come to the list here, just kind of keep in mind that this is an evolving thing. Some of these things are what you would actually think of as a distribution. So in particular, this Aricto Enterprise Kubeflow, that is a managed Kubeflow distribution that's available on 3 major cloud providers, and, you know, has enterprise support from Aricto. But things like the AWS, Azure, you know, these pieces here, this is really more just documentation. And I found it difficult to follow, frankly. When I did on Google Cloud, I tried to get started there. You have to deploy a management cluster, then you have to install a thing into that, then that goes and creates another cluster. If you're using the free account like I was, then you're going to run out of resources. You're going to have to request a quota increase. It just wasn't as easy to get started. Now, the mini KF distribution, that's absolutely like either a Vagrant box or a virtual box. Very easy to get started, just starts up. It's basically Minikube with Kubeflow installed. So that might be a better way to get started. The other thing that I'd say too is if you are on Google Cloud and you want to spend some time with Kubeflow pipelines, they have that in the app catalog. So you can just go and say, hey, I'd like to have Kubeflow pipelines, and it will install it. The downside using Kubeflow on Google Cloud, from my perspective, is that Google Cloud already has a lot of managed services for some of the things inside of Kubeflow. So like, for example, if you wanted to do a Jupyterhub notebook, Google Cloud has a service for doing Jupyter. And so they want you to use that, which is VM based, instead of using that in Kubeflow. So you really can only get the Kubeflow pipelines piece. There's some integration before, but it's not like, it doesn't feel like a Kubeflow experience. It feels like kind of a hodgepodge. And I've used the IBM Cloud AI services as well, and it's very similar, right? So they have a bunch of stuff that's Watson stuff. They might want you to do your notebooks in that, and then do, you know, something else for TensorFlow. So anyway, your mileage may vary with those. But like I said, if you are familiar with Kustomize, that's really good. The other thing that I'd point out is that there is a Kubeflow operator, and that is in the operator hub, like operatorhub.io. And this is what we'll be looking at tonight. To me, this is way easier than anything else. The only downside is that it is only version 1.2 The current version of Kubeflow is 1.3, and there's a 1.4 release that's imminent. And it seems to have been somewhat abandoned. So I guess I'd say, so it's a few guys from IBM that have been working on it. And if you go look at their roadmap, it doesn't have anything past like 2020. The other thing that I'll note to Joe's point earlier is that this is a stage 1 operator. You can see here at the bottom. So it has a basic install functionality. You basically tell it, hey, this is what I want. Go make this happen for me. But it doesn't have upgrades, full life cycle, deep insights, or autopilot available yet. So, but this is an easy way to get started as well if you're not comfortable with customize and you don't want to try the distribution method. All right, let's talk about pipelines for just a minute. So this is a particular thing in Kubeflow that is not in OpenDataHub, which is the next thing we're going to look at. Kubeflow pipelines, they're kind of like Tekton pipelines if you've worked with them in the past. I think the thing that's different about Kubeflow pipelines from Tekton pipelines, in Tekton pipelines, you define actions, and then you kind of build a pipeline out of those defined actions. Whereas Kubeflow pipeline, you basically take it's much more like a Jenkins pipeline. So you kind of describe, yeah, I can do that for sure. I'm sorry, it's a little fuzzy image. You define the steps that you want to take in the pipeline as little bits of Python code inside of kind of a larger YAML interface. And then you define the outputs from each of the steps, and then they become the inputs to the next step. I'm not going to cover Kubeflow pipelines a lot tonight because it's a whole nother topic that you want to dive into. But it is a kind of major feature of Kubeflow if you're using Kubeflow, and it's worth taking a look at, right? When you're doing pipelines, each pipeline that you run can be grouped into experiments. Experiments have runs, and they have artifacts and executions and things. So it's kind of its whole, a whole kind of ecosystem for how to approach the data science and the ML workflow, assuming that you're using, all of the components in Kubeflow. Cool. Actually, let me keep that maximized for the next slide. Okay, so Kubeflow, kind of walk through that and what that looks like. So what is OpenDataHub? Because that's what we'll be looking at tonight in the demo. Maybe, I don't know, a couple of years ago, 3-4 years ago, we at Red Hat brought in a team of data scientists because everybody has to have a team of data scientists, right? And when the data scientists got to Red Hat, they said, hey, okay, we need these tools. We do this thing, we do that thing. And we said, oh, okay, well, we use OpenShift. And they said, oh, okay, well, that's kind of like Kubernetes, right? So we'll do Kubeflow. There were a couple pieces of Kubeflow that did not work well with OpenShift, right? So OpenShift has a lot of security constraints as far as what containers are allowed to do in certain contexts, bits and pieces like that. So OpenDataHub was kind of created initially as, let's get Kubeflow working on Red Hat OpenShift. Over time, it has turned into something very different, which is much more of a kind of open community style project. It's not just a Red Hat thing. The main differences between Kubeflow and OpenDataHub are, first of all, OpenDataHub adds a few manifests. So there's some pieces of software in OpenDataHub that are not available in Kubeflow. All of the things in Kubeflow are available in OpenDataHub, but there's some extra OpenDataHub stuff. A lot of it built around consuming other things that Red Hat has kind of put together to run on Kubernetes via operator. And then the other thing that's different about OpenDataHub is it is absolutely 100% operator based, right? So it is still doing customize under the covers, but you never interact with the customize manifests like you would with Kubeflow. They're kind of the two big differences. You'll see there's a lot of like Red Hat registered stuff in all the different boxes here, but all of these pieces are all open source pieces, that you can pull, off the web. So for example, one that we'll be using tonight, you know, on the slide here is labeled as AMQ streams, but upstream, that's Kafka Strimzi operator, which is a part of Kubeflow as well. So this is the solution to the first problem. Like I mentioned, the first problem was, how do I get started? You know, I know the problem. I know what my data looks like. I just want to get to the computer. You know, the solutions to this, you know, the Kubernetes solutions are things like Kubeflow and OpenDataHub. And then let's take a quick look at what that looks like from the demo. So let's take a look here. So the first thing that I mentioned, so OpenDataHub and Kubeflow, when you use the operator, create a custom resource definition called a KFDef. This might be a little small. See, I don't know if I can easily make it much bigger. You can see that here. A KFDef stands for Kubeflow definition, right? It is a very simple style of object. So the first thing that you do is you specify a name for it. So just like any other custom resource, you know, I can have more than one KFDef inside of a namespace, and you know, I would give them each a separate name, right? And then really there's two more pieces, right? So there's the spec, which we're going to create a list of applications. Basically what we're doing here is we're selecting, you know, kind of piles of manifests from the general kind of Kubeflow pile of manifests. But if you're not a customized manifest, you can just think of them as selecting applications out of the pile. It's kind of what I would think if you're not a customized person. And then the second piece is the actual repos themselves, right? So this is specifying the version of the manifest that we're going to be using to build out our data hub. And you'll note that, as I mentioned, like we have the Kubeflow manifest here. So we're using the 1.3 version of Kubeflow. And then in addition to that, we're using the 1.1 version of the ODH manifest, which give us some additional bits and pieces. So let's take a look and see what I have here. In this KFDef, I have the common stuff that we need. I'm going to be deploying some object storage. So I have something I thought was really amazing. I hadn't seen it before. It's called Ceph Nano. It basically runs Ceph in a single pod. It's pretty awesome. Provides you with an S3 interface. I'm also going to be deploying Grafana and Prometheus because I need those, and then Jupyterhub. And then you'll notice here that I'm overlaying, you know, a set of notebook images on top of my Jupyterhub deployment. And that's it, really. So, you know, either I could have written this or I could have gotten this from somebody. When we do workshops, I hand this to the participants and they create it themselves. And once I have it, I can just do, you know, kubectl create -f OpenDataHub KFDef. And it will create me an OpenDataHub. So now I can do kubectl get KFDef. And you can kind of get a feel for it. If you want to go back and figure out, you know, what was you deployed, or if you wanted to reuse one that you've already gotten, works just like any normal CRD in Kubernetes. So let's take a look at what happens here. So I had nothing up my sleeve, I promise. But here you can see in just a matter of, really just a matter of a minute or so, I have my Ceph Nano pod is up and running. I have a Grafana operator, a Prometheus operator. I have a Grafana deployment. I have a Prometheus deployment. And then I will also get pretty quickly here a Jupyterhub deployment. Just kind of wait for that to get started. But as a, you know, like I said, as coming to this initial problem of, you think about the guy that I was working with who had the new data scientist come on, like he had to reach out for help to get a lot of that software configured and installed, just because it was a totally foreign world to him, right? In this scenario here, all I had to do was install the OpenDataHub operator, and then hand someone a single YAML file, and they have a complete deployment of everything that they need to get started. So that's pretty amazing from my perspective. Once you get going, you will get Jupyterhub. Let me start with one that I already have here. We've already got one in the oven. And I want to just walk you through what Jupyterhub looks like if you have not seen it before. Yeah, we're going to have a lot of fun once we get to the bigger picture here, but let's start with Jupyterhub. So this is kind of the humble user interface, I would say, of Jupyterhub. It's kind of small, but this is what I got. So the first thing you can do in Jupyterhub when it runs in Kubernetes is you will get some kind of, I would say it's somewhat ephemeral storage attached, right? So if I were to restart all the pods, I think I would lose my ephemeral storage. But assuming that the kernel is up and running, the file system will persist. If not, no big deal. You can get a terminal and you can kind of do a git clone. Hang on here, come back. You do a git clone. You have some kind of space on the file system. Newer versions there's a Jupyter Labs, which is kind of a nicer version of Jupyterhub. It actually has somewhat of a graphical interface for Git, but for just getting started here, you can see that I've cloned a set of labs that we work on that have some notebooks and services in them. And once you clone them down, like this, you can open up a notebook. Every notebook that's running inside of Jupyterhub gets what's called a kernel. So it gets kind of a little version of Python that's running inside the container there. The kernel, when you restart it, it does lose state, right? So whenever you're kind of starting out using Jupyterhub, one of the first steps that you'll typically do is download all of the Python modules that you need. These are already installed here, but you can see I'm kind of importing them on the get-go here. If you've never seen a Jupyter notebook before, but you have seen Python, you will recognize that here's a cell full of Python code. The notebooks themselves are made up of these cells. The cells can be text cells, they can be Python code cells, but it allows you basically to take a bunch of Python code that you want to run and turn it into a narrative. And so this is an amazing tool if you're trying to figure out what other data scientists are doing, or if you want to show someone the work that you've done. And it has become kind of the de facto data science tool. If you go to like kaggle.com, there are thousands, if not hundreds of thousands of Jupyter notebooks that were put together by real data science people that they've made available publicly for you to be able to go and see what their work was and understand how they're approaching a problem and then to replicate it on your own. So it's a very cool open source community. Each one of these cells gets executed by itself when you click the run button. So here you can see it ran this cell. What I'm doing here, just so you know, kind of back at the beginning of the pandemic, I spent a lot of time kind of playing with the numbers just because I was trying to understand what was happening and so on and so forth. But this became kind of my pet project for a minute, is to look at COVID data and then kind of play with that a little bit, just because I was doing it anyway in spreadsheets, right? One thing that's important to note about about data science, these guys love CSVs, right? So I don't know, I don't know why, but everything's in CSV format. I guess, in reality, like maybe it's easier to do CSVs than to do Microsoft Office or whatever sheets. But you're not a real data scientist if you don't start with a comma separated value sheet. It's just the way it is. So anyway, I pull a CSV down and then I turn it into what we call a data frame in Pandas. We don't really have time to get into all that tonight, but you can think of a data frame kind of as the CSV turned into something that you can manipulate. This is a data cleansing example. So I take that CSV file down, I sort the values, I drop some stuff that I don't care about, I do a couple of quick checks on it. And then you can see this is what the data frame output looks like. Just like you'd think, it's like basically it's a slide in a, oh my gosh, wow, did we get, that's like the dad joke of the day. It's awesome.
You're welcome.
I needed that. You know, it basically looks like a spreadsheet, right? And then, you know, we get to do some graphing. You can kind of look here, like if I'm doing data cleansing and I see that bump right there, I'm gonna think there might be an issue. And then in particular, you see I've got this bump right here. You know that that's a bad form, right? So how do we take care of this? Like if I wanted to get a clean plot of deaths by date, I can do a thing called a quantile filter. You can see I know a lot about data science. And then once I get the filter, I can graph again, and you can see I took out my bump. Anyway, this is just kind of to give you a feel for what a Jupyterhub notebook is, and you know what a data scientist is doing in this initial phase of looking at data, visualizing it, trying to figure out what the features are, so on and so forth. I'll take a quick break there. That was, I think, what I wanted to show you at that point. Let me come back to the slides. So like I mentioned, you know, problem number one was how do I get started doing the thing? And then problem number two is where I think things get pretty interested. Is just a quick plug of, you know, some OpenDataHub projects here. You know, one thing I think is different. We are using, we do have Ceph in there, which is great. I don't think there is Ceph in Kubeflow. There is Argo. Though, and there's also an Argo flow if you wanted to use Argo CD to deploy Kubeflow. All right, so problem number two is the kind of more interesting problem, which, like I said, you know, we keep coming back to this. There's 5 lines of Python I got to run. I got to run it 1,000,000 times, but how do I get the code to the 5 lines of Python? How do I run the 5 lines of Python? You know, and then how do I monitor it, and so on and so forth. If I'm an application architect and it's 2021 and I'm looking at this problem, you know that the only solution to the problem is absolutely going to be, well, microservices, of course, right? So, you know, by default, it's going to be microservices. It's probably going to be on Kubernetes. It's definitely going to be containerized. But in reality, this is a really good approach to the problem. And Jay, I'll get back to your question in just a second. And the reason for that, like I said, it is a very small amount of code that you're trying to execute to actually apply your model to something coming in and do a prediction. And all of the other things that you're doing, as far as like taking the output of that and emailing it to somebody, or putting the image up on, you know, a mobile app, or ingesting data, or even data cleansing, like all of those things are kind of one-time, kind of small things that, you know, can live in their own problem domain. So if you think about kind of normal microservices architecture, what I'm doing is I'm taking a website and I'm breaking it down into the shopping cart, you know, the billing piece of it, the shipping piece of it, the customer information piece, so on and so forth. We're going to do the same thing to data science, right? So I'm going to take each one of the pieces of this workflow and break them into microservices, and I'm going to run them just like that. So now that we know that microservices is the only solution to the problem, because of course it is, the question about how do we actually do the communication is very important. So in a lot of service-oriented architecture, you know, things are driven by people making calls out to each other, right? In, you know, kind of modern microservices architecture, there's definitely a lot of that going on. But the particular method of communication that really works best in these kind of workflows, at least from my perspective, is event-driven architecture. So what is event-driven architecture, EDA? basically, instead of each one of these microservices making synchronous calls to each other over a REST API or something like that, each one of these microservices is going to drop in on a Kafka topic. And as events come in, they're going to be updating each other with messages on the queue, right? And that it doesn't have to necessarily be Kafka. Like you obviously could do this with AMQ or something like that. But Kafka is a really good way to do this kind of thing, right? So, and like I said, you know, kind of go back and forth on this at all, but from my perspective, applying event-driven architecture and microservices architecture to data science makes so much sense, solves so many problems, and makes it really easy to do crazy scaling. So now that we've made these decisions, obviously we made the microservices decision because you have to, we made the event-driven architecture decision because we think that's kind of smart. And like I said too earlier, like you could absolutely go the pipelines route. So the Kubeflow pipeline, like, is definitely not a microservices architecture. It is, you know, each one of these pieces of Python getting executed either serially or kind of decision tree execution or things like that. You know, once you've made either one of these decisions, you're still going to have a problem where you have to pass state. And each step in the process, whether it's the pipeline or whether it's whatever, there's definitely data that needs to get dropped somewhere. And, you know, obviously the first piece of data is you got to have the CSVs somewhere. And the place of choice to put the CSVs is in an S3 bucket. If I was to do it all over again, relational databases are really good at storing, you know, lines in a table. But like I said, everyone likes to do the CSVs in the S3 bucket. So that's a piece you need. You need to have something like that. If you do not have kind of an S3 or object storage capability in the public cloud that you're running on, if you're running on-prem, or in particular, if you're running at the edge, using something like Ceph to give you S3 capabilities, or people use that Portworx thing too, is particularly good, just to make sure that you have object storage. And the good news about using Ceph is that it is S3, and most of these things are compatible. So if I've written a notebook or a piece of Python code that's used to talking to S3, it can talk to Ceph just as easily, which is great. And then there is still a place, CSV joking aside, for relational databases if I'm storing metadata or things like that. And the pipeline that we're going to look at, we absolutely use a Maria database. So I think that's a good idea. Jay was asking about CI/CD. That's kind of interesting thought, yeah, because when we start at the beginning, we're thinking about you know, the machine learning workflow as a software development workflow. Both of them are like very iterative. Obviously, you want to be testing things. I actually have not seen a lot of CI/CD applied in machine learning. It seems to me like machine learning in data science, like the data scientists still like to do kind of bespoke twiddling around with each one of these, you know, each one of the notebooks that they're working on. And then the question is, how do you get from the notebook out to the rest of the thing? And we've been working on some stuff at Red Hat where we can actually take a notebook, kind of extract the Python or the model, and turn it into a Flask app. That's a project that we've been working on in this OpenShift data science kind of project that we're doing. I don't know. I mean, to me, it still seems like the actual data science piece of it, where I'm going through the notebooks and doing all that stuff, you're going to be doing outside of a traditional software development, continuous development workflow. But then once you get to the actual model deployment, I would just do that like you would do anything, right? So that's, you know, these are microservices. You're deploying them into Kubernetes. If you use Argo for that, you know, that works great. If you use you know, Jenkins for that, that works great too. You know, if you wanted to use Tecton pipelines, you could even use Tecton pipelines to do that. And basically, you're just trying to get that container image out there so that you can then orchestrate it inside of Kubernetes. in addition to that, the last kind of important piece that we have to think about, problem domain that we need to approach model deployment with, is around observability, right? So it's the same thing as anything else that I'm putting out onto Kubernetes. I need to be monitoring the health and wellness of my applications. I need to also, in the case of data science or machine learning, I also need to be monitoring the performance of my model. So is my model performing really well? Is it performing worse? Is the performance getting better or worse? Am I trending? Does this model perform better than another model? How do I visualize these things? The cool thing about this is we've gotten so good at doing this in Kubernetes that it just immediately applies, right? So, you know, you say, oh, well, I use Prometheus and Grafana for that. And then if you think about when we do cloud native microservices, you know, there are well-known patterns for doing health checks and things like that as well. So you can take, you know, metrics and health checks, anything that you would do in normal microservices application development, and you can absolutely apply that here to the machine learning model deployment. So enough about that. Let's look at an actual example, because this will be kind of the fun part of the whole thing. So what am I going to do here? I'm going to do X-ray image classification. The reason I'm doing X-ray image classification and not liquor bottle image classification is we are still fine-tuning the liquor bottle image classification pipeline. It's a little trickier. But X-ray images we've been doing for a long time. We have a project at Red Hat called Chris. It was something that we developed with the Boston Children's Hospital. And the idea there, and this was a few years back, was to take, I think they use TensorFlow and Keras, to analyze MRIs that come in from children who show up at the hospital and look for tumors, either that a radiologist might have missed or just to kind of verify what the radiologist is doing. And there's kind of a long history of this. It turns out that TensorFlow and Keras are really good at learning to spot abnormalities in radiology images. So either X-rays or MRIs or CAT scans or things like that. And the X-ray image classification, super simple. You know, the data sets are widely available. And so that's what we're working on tonight. I will say it is a little creepy to be looking at checks just raised. So just kind of brace yourself. If you're of the week of something, then you know, avert your eyes when I start showing you random people's X-rays. So what is the pipeline that I've created here? Yeah, well, Alex, I'll come back to why the liquor bottles are so complicated, but it is actually pretty hilarious. Yeah. Anyway, but what is my project? So remember what I'm doing here. I'm applying event-driven architecture, microservices architecture to the data science workflow. The thing that's actually doing something is going to be this risk analysis service. And like I keep saying, this is the 5 lines of Python. This one is very, you know, this is important. Now, the way that we've set this thing up here, because I'm obviously, because I'm using Kubernetes, I have the ability here to use Knative for this. And so this actually runs as a Knative service. And there's a sink that I've attached to my Kafka bus. So it only starts up when there are actually images to analyze, which is super cool. So I'll show you how that works. We do not have an X-ray machine available tonight, unfortunately. So I cannot take a live X-ray and put it into here. So what we're going to do instead is we have a little microservice that runs and grabs images out of an S3 bucket, pretends like it just took an X-ray, and it's going to take the image, it's going to drop it into an S3 bucket hosted in Ceph. It's going to put a little bit of metadata in a MySQL database, and then it's going to drop an event on the Kafka topic. And then, like I said, we have Knative. Is going to see that event came in. It's going to fire up my analysis service. It's going to run my 5 lines of Python. That is going to label the image as either, in this case, we're looking for pneumonia. So it's either going to say this is normal or it has pneumonia or I don't know. and it's going to drop the labeled image into another S3 bucket. If it doesn't know, it's going to anonymize the image by blurring out people's names and stuff and drop it into a third S3 bucket to be analyzed by a human. It'll update the metadata and then kind of move on. The last piece here is I have a microservice that we can use to look at the images inside the buckets. And then finally, we have a Grafana dashboard. So I will say I did not write most of this code. It's like I said, I have a correspondence course degree in data science. There's a really cool guy, Guillaume Moutier, who works on our storage team at Red Hat, who kind of put most of this together. And then I did some special modifications, I guess I would say, over the last year as we've been working with the project. Cool, so let's take a look at it. Let's see what it does. So first, let me show you the notebook. So if I come back to here, this is the notebook that I can use to predict the images. So the original notebook, so like I said, we kind of pull this stuff off of Kaggle, right? Give credit where credit is due. Here, I guess this is Alexander Kosovan. No idea who that guy is, but 3 years ago, he wrote this notebook. And he's explaining here how he uses TensorFlow to look at these chest x-rays. And then the data set that we're using is also on kaggle.com. This is 1.2 gigabytes of chest x-rays. Now, it's really important when you're doing the training here, you have to label the images, right? So I have a pile of normal images and I have a pile of pneumonia images. Basically, I'm going to feed that to TensorFlow and I'm going to say, hey, figure out what's normal and what's pneumonia, and then let me know. So that's kind of what we start out with here. So if I run through the notebook, like I said, we have to have our imports all ready to go. I have my training data is already downloaded into here. You can see this is a normal image of somebody who does not have pneumonia. So we're loading that. And then here is an image of somebody who does have pneumonia. All right, and we're loading that. This is kind of the magic of the whole thing. And this is why Kaggle is such a great reference. Like when we were looking at the liquor bottle problem, I'll have to just show this notebook in a minute. This is what we call a binary classification, right? So I'm looking, is it pneumonia or is it not pneumonia, or do I know? That's a different problem than here's a random liquor bottle off the shelf. Can you tell me what it is? And so we had to use something called serial classification on the liquor bottle problem versus binary classification. Anyway, you can just go to Kaggle and you can find someone else who's already done this, and they will tell you, how many training samples to use, how many validation samples, how many epochs, things like that. Kind of the magic here, which doesn't make any sense to me at all. But before it does the image classification, when it's building the model, it actually does a bunch of weird stuff to the image. Basically think of it as putting it through, a series of 12 Photoshop filters. And coming out with something that doesn't look anything like an X-ray image anymore at the end of it. But to a computer, it's able to somehow use these convolutions and flattening and things like that to get an image that it can recognize is the difference between the two. And you see I have a little more information about my model here. And then I'm just stepping through all the different steps. Take up too much time tonight. This is kind of the magic, right? So at this step, what's happening is it's taking all those training images that I put, and this such as smaller data sets, is hundreds of images. It's putting all the filters on them, and then it's applying what I can only imagine is a neural network to attempt to figure out a model that will do predictions, right? And as it runs through each one of these different sets and scenarios, what it's trying to do is find the highest accuracy, with the lowest, I forget what we call it. The thing, I guess it's loss or something like that, that is not the accuracy of the model. We're going to let this run. So this is where kind of I think as a data scientist, I've kind of gotten to this point. Super useful to have some GPUs available. And in particular, like this one, this will complete in like maybe 10 minutes. But liquor bottles, that's taking like 20 minutes to run through the model training. This is a very different kind of style of problem, right, to solve. Once you get it done, then you're kind of down to the 5 lines of Python. So let me show you those. Excuse me. And there's definitely some scaffolding here. But the reality is all that I am trying to do. Let me find it here. Is that right there, right? So I get the image, I run prediction on it. And if it is 80% or higher confident that it is pneumonia, it's going to label it as pneumonia. If it is less than 60% confident that it is not pneumonia, then label it as normal, and then anything in the middle gets labeled as unsure. And that's pretty much it. So what is all the stuff around it, right? The stuff around it is consuming the image. So since I'm using Knative, what will happen is Knative will grab an event off the Kafka bus and basically post an HTTP request into this Flask app. It'll kind of get the data into the app. And then there's, saving it into the bucket, updating the metadata, bits and pieces like that. And like I said, these are all software development problems. These are not data science problems. Here I am updating my SQL database. And then there's the bits and pieces where I actually ferry the data and do the S3 stuff in here as well. But anyway, it's a single Python file. It's very little code, and I run it as a microservice in Flask. So if you look at kind of the big picture here, that service, you can see here, is a Knative service. If you have not used Knative before, I guess it would be hard to do like a quick Knative overview, but basically what you do is when you create a Knative service, you tell it, hey, here's a revision of the service. It's this container image. And then assuming that Knative can run the service, then when traffic comes in, it will ferry it kind of into the service. And then you can tell it, over time, hey, now this is my new version of it, and so on and so forth. So that's what the revisions piece is. And the revision,
Just a quick interject. If anybody's curious about Knative, we had one of the maintainers, Scott Nichols, come and speak in April, and that recording is available on YouTube.
Even better. So definitely go watch that guy because he knows way more about Knative than I do, for sure. I also have a correspondence course in Knative that I took too, right? But anyway, so revisions, is kind of what this is. You can see right now that it is scaled to 0. And this is a wonderful thing about Knative, and probably one of the biggest reasons to use Knative if I'm looking at what's the architecture I should be using here. If you are doing computationally intensive types of things, you're probably using GPUs. GPUs are expensive, whether they're in the cloud or they're in your data center. Only using them when there is something to process is way better than using them all the time, right? So excellent choice there for Knative. You'll notice I also have a Kafka cluster here. So like I said, the upstream for this is called Strimzi. It's an operator. The CRDs that I have here is I created a Kafka, which gives me a cluster. I created a Kafka topic for the applications to use. And then I did do a sync, which basically tells it, hey, when you see an event on the X-ray images topic, to feed it into the Knative service. Like I mentioned, I have 2 other microservices here. I have the image generator. This is the one that's simulating grabbing X-rays. I have the image server, which will show us, images that have been processed. These are just pods. I built them off a Python 2.7 image, piece of cake, nothing to it. And then I have the infrastructure here. So Ceph Nano, it runs as a single pod. Like I mentioned, the cool thing about Ceph Nano, when it starts up, it will create a secret called Ceph Nano credentials, which will give you an access key and access key ID to use. And then from then on, it functions just like a normal S3 endpoint. So that's super great and easy to use. The other pieces here, we looked at Jupyterhub earlier, Prometheus and Grafana. I'll show you that in a minute here. The Grafana operator exposes two CRDs that I used here. One of them is a dashboard, and then the other one is a data source. So I could tell it, hey, you have a data source, which is this MySQL database, and then here's a dashboard definition as well. So now let's watch the thing happen, right? So this is kind of the cool part. You see my image generator is scaled to 0. So we will scale it to 1. At this point, if you remember, it's grabbing an image off an S3 bucket. It's putting it into the Ceph bucket. It's dropping the message on the Kafka topic. And what should happen here once it starts up, and it does, you can see that the sync saw that there was an event on the bus, and it fired up the risk assessment service here. And now once the risk assessment service runs, it will label the image, and then we will be able to see it here on the image server. So you can get a feel for what it's doing. So this is the last image that went up into it. The first time I looked at these, it's super jarring, right? Because it has personal information. I don't know if that's real personal information or not, but it's definitely nothing I took from anywhere that shouldn't have been legitimate. So anyway, it totally threw me off when I first saw that stuff, but there it is anyway. Or maybe Vonda decided she was going to release her images for the good of science or Kubernetes meetups. But anyway, there's the image. Then you can see here's the last image that it processed. And just like we saw in the code, so this one, it said, this is definitely not pneumonia. Although when I look at this image, it sure looks like pneumonia to me, but it says it's normal. The risk of pneumonia is only 10% on this image. And then here's one where it wasn't sure. So the risk, remember, is between 60 and 80. So that's kind of the danger zone where it could be pneumonia, could not be pneumonia. So it labeled it as unsure. And then you'll see down here at the bottom, it blurred out that personal information that was on the other X-ray. So you can see the pipeline is working. And this is somewhat useful, right, to look at it from this perspective. But what you really want is you want to do some monitoring of it. So here, I have a Grafana dashboard. And you can see here, this dashboard is keeping track of how many images are coming into the bucket. And it's pulling most of this from the Maria database. It's checking, to see, are these things coming out as normal or pneumonia? So you can see the bulk of the images are coming out as normal. There's a smaller number that are coming out as pneumonia, and then there's an even smaller number where it wasn't able to make a correct prediction. What you're kind of looking for here over time is you don't want it to not know how to make the prediction more than it needs to. Also, you could look at this and you can say, hey, it's highly unlikely that everybody's got pneumonia. So if everything's coming back pneumonia, then this thing is performing poorly. So it's kind of the way you want to do that here. There's also an idea of a version of the model. So when we do this kind of in-depth in a workshop setting, we will go train the model again using some different settings and get a slightly more accurate model. And then you'll be able to watch, what's being processed by version 1 versus version 2. We can do kind of a blue-green deployment or a canary deployment of the new model, just like we would do with normal applications. and check, performance of the 2 different versions that are running. And then you can also see kind of, just a bit of a dashboard on the images here. Now, what's super fun about this whole thing is, like, let's say I only had one of these pods running. Let's just go ahead and scale this up to 4. And to me, this is kind of the ultimate kind of amazing greatness of Kubernetes. Is it, if you've done everything pretty much right, all of the scaling concerns and deployment concerns and stuff like that will be handled by the platform. And you shouldn't have to think about it that much, right? So now at this point, I should be getting, more and more traffic into my risk assessment service. We should see a lot more images getting processed as it goes ahead and scales as a Knative service. So you see it's starting to come up here. So there's that. Let me take a quick minute here and just show you for fun. I think user 2 had the cool new project we're working on. If you haven't ever done any data science, I got to tell you, like, it is way more fun than you would think it is. And like I said, it's very easy to get started. You know what you're doing here. So we can see this is our new project that we're working on. Like I said before, the initial one was a binary image classification. We're looking for pneumonia, not pneumonia. This Ken, who works with me, is working on this one. This is a sequential model. So what he did, is he took initially something that was supposed to identify flowers, right? So he's got like tulips, dandelions, roses on a cake, I guess. And then he labeled liquor bottles, and he had a bottle of Hendrix and a bottle of Herradura. But he said that the trick to it was, for the model to get good, like, you have to just take a whole bunch of different kinds of pictures of a given thing, right? And so, he's kind of running around his apartment trying to find all these different ways to take the pictures. And then you'll notice here, in this notebook is fantastic, but one of the other things that it does is it will perform all these strange convolutions on the images here. So let me see it. Just this one, for whatever reason, it picked the images. Let's see if I can get it to pick. Yeah, so it takes a particular image of a liquor bottle and then turns it around, or maybe flips it, or so on and so forth. And you do all this augmentation, and then the model gets better at actually identifying the thing. Anyway, like I said, it takes, I guess it took about 20 minutes the last time that I ran this model. But in this one, there's a whole lot more kind of information. So like I said, getting started with data science, it can be a lot of fun. It can be, especially if you have a cool problem that you want to solve. Kaggle is an amazing resource. There are thousands and thousands of kind of getting started notebooks that you can use. And hopefully, with either with Kubeflow or with OpenDataHub, it is relatively easy to kind of get off the ground and get these tools, available to you. And eventually even, take a model that you've developed and deploy it in an immensely scalable way. All to the magic of Kubernetes. So that's my talk. Any other questions? Cool. Yeah.
Anybody got any questions left to ask Michael before we wrap up? Go ahead and feel free to post them in chat or in the QA feature. Nothing coming in so far.
It looks easy. It is really easy. That's kind of the magic. Yeah, it's really, really easy and fun. That's awesome. Cool.
Great. Awesome. Can share steps in doc. So Raj asked, I think, can you share the steps in the doc?
Let me do this.
If you drop the links, Michael, we can add them into our Meetup notes that go along with today's Meetup and push them out to the Meetup Git repo.
For sure. This is, so like I said, we run this stuff as a part of a workshop. This is the guide for the workshop that we use. That kind of would walk you through building out everything that I have there.
All right.
Anybody else got questions? I don't see any others coming in, so Joe, go ahead.
Sure. So we'll wrap things up here for the presentation portion of the meetup. A couple of things to go through before we get into the social portion. So bear with us for a little bit longer. First, want to start by again thanking our sponsors, Sales Law, for the Zoom and some of the other things that make things go behind the scenes. Also, Michael, thank you again for coming out virtually and talking to our community here. I think this was a really cool topic. Hope to see you back in the future.
Yeah, for sure. Anytime.
And then, as always, the ask out to our community folks here is if you have any topics that we have not covered that you would like covered, or you have a topic that you would like to present on at one of our meetups, please reach out. Many different methods, either through the meetup group itself in Slack, in the Kubernetes Slack or Tech 404 Slack, as well as our KHATL GitHub repo. Feel free to reach out in some way. One thing to note on that is October is typically our last normal meetup of the year. And then we try to do something social in, December, November timeframe. Social stuff might be a little weird this year, so to be determined on that. But again, please reach out. We love to have speakers from the community. So that all being said, thanks everybody for coming out. Stick around if you want to have some social time.
Thanks, everybody.